Good day, Acute Angels. I am Teacher Nancy, your Mathematics 8 teacher. For this week's lesson, you will learn how to illustrate a relation and a function, verifies if a given relation is a function, and determine dependent and independent variables. Let us first talk about relation and function. In life, a relation involves the association of an individual or object with another individual or object. Relation also exists between mother and child, husband and wife, teacher and students, or among animals and their young. Relations between objects may also be identified, such as spoon and fork, nail and hammer, country and its capital, name of a chemical element and its symbol, and many more. While in mathematics, a relation is a set of any one or more ordered pairs, where the domain X of a relation is the set of first coordinates. The members of the domain can be called inputs. The range Y is the set of second coordinates. The members of the range can be called outputs. For example, suppose you are working in a fast food company. You can earn 40 pesos per hour. Your earnings are related to the number of hours of work. Here are some questions. How much will you earn if you work 4 hours a day? How about 5 hours, 6 hours, 7 hours, or 8 hours? Number 2. Express each as an ordered pair. And number 3, based on your answer in number 2, what is the domain and what is the range? Here are the solution. For number 1, the amount of money you can earn working for 4 hours a day is 160 pesos. How did we get that? We multiplied the number of hours we work to the amount of money that we can earn per hour. So that is, the number of hours is 4 times 40 pesos per hour. That is 160 pesos. So, in 5 hours, we can earn 200 pesos because 5 times 40 is 200. And for 6 hours, we can earn 240 pesos. For 7 hours, we can earn 280 pesos. And in 8 hours, we can earn 320 pesos. For the question number 2, express each as an ordered pair. We have the first ordered pair, 4, 160. The second is 5, 200. The third one is 6, 240. The fourth one is 7, 280. And we have the ordered pair, 8, 320. Based on your answer in number 2, what is the domain and what is the range? We know that the domain is the set of the first coordinates. So we have 4, 5, 6, 7, and 8 as the domain of the relation. And we have 160, 200, 240, 280, and 320 for the range of the relation. Here are some examples of relation written as ordered pairs. We have the set 4, 160, 5, 200, 6, 240, 7, 280, 8, 320. We also have the set 1, 4, 2, 5, 3, 6, and 4, 7. And the last one, we have 1, 2, 2, 5, 2, 0, and 3, 7. Because a relation is any set of one or more ordered pairs. We can also present a relation by using a table, mapping diagram, graph, and rule. For the table describes clearly the behavior of the values of y as the value of x changes. We can use a vertical table or horizontal table. For the mapping diagram, we have this example. This mapping diagram shows 4 is mapped to 160, 5 is mapped to 200, 6 is mapped to 240, 7 is mapped to 280, and 8 is mapped to 320. I will give you more examples of mapping diagram later on. For the graph, we have this example. To represent a relation by using a graph, we just have to plot the set of ordered pairs of the relation. And for the rule, look at the table. This was from our first example. Notice that the value of y is 40 times the value of x. In other words, this can be described by the equation y equals 40x, where x is the number of hours and y is the amount earned. So to get y, we just have to multiply the number of hours. For example, we have 4 as the number of hours. Multiply it to 40, we get 160. Next, for 5 hours, multiply 40 times 5, we get 200. And for 6 hours, we have 40 times 6, the result is 240, and so on. So as the number of hours increases, the amount you will earn also increases. We also have correspondence. Correspondence may be classified as one-to-one, many-to-one, or one-to-many. It is a one-to-one correspondence if every element in the domain is mapped to exactly one element in the range. As you can see in the mapping diagram 1-to-1, each element of the domain is mapped to exactly one element in the range. We have -2 is mapped to -4, -1 is mapped to -2, 0 is mapped to 0, 1 is mapped to 2, and 2 is mapped to 4. Therefore, this one is a one-to-one correspondence. We also have many-to-one. It is many-to-one if any two or more elements of the domain are mapped to the same element in the range. So for the many-to-one diagram, so we have two elements from the domain that is mapped to exactly one element in the range, that is -3 and +3 that is mapped to 6 from the range. We also have -2 and +2 from the domain that is mapped to exactly one element in the range, 2. And -1, +1 from the domain is mapped to exactly one element in the range, which is 4. And lastly, we have one-to-many correspondence. It is one-to-many if each element in the domain is mapped to any two or more elements in the range. So that is, in this example, the element in the domain 1 is mapped to two elements in the range -1 and +1. The element in the domain 4 is mapped to two elements in the range -2 and +2. And the element 9 in the domain is mapped to two elements in the range -3 and +3. So this one is an example of one-to-many correspondence. Next, we have the function. What is a function? A function is a special type of relation. It is a relation in which each element of the domain X corresponds or maps to exactly one element in the range. In simple terms, it is a special type of relation wherein no two ordered pairs have the same abscissa. Thus, a set of ordered pairs is a function if no two distinct ordered pairs have equal abscissas. Hindi pwedeng magkaroon ng isang value ng X para sa dalawang Y. So, hindi pwedeng magkaroon ng isang X for the two elements dun sa range or Y. The following characteristics of a function will help us decide when we test for a function when two sets of numbers are given. Here are the characteristics of a function. Number 1, each element in the domain X must be matched with exactly one element in range Y. Number 2, some elements in Y may not be matched with any element in X. And the third characteristic, two or more elements in X may be matched with the same element in Y. So for example, let us determine if the given relation is a function or not a function. So for example number 1, we have the set of ordered pairs 4, 160, 5, 200, 6, 240, 7, 280, and 8, 320. Let us look at each element in the domain and the range. Each element in the domain 4, 5, 6, 7, and 8 is assigned to no more than one value in the range. 4 is assigned to 160, 5 is assigned to 200, 6 is assigned to 240, 7 is assigned to 280, and 8 is assigned to 320. Therefore, this relation is a function. For number 2, we have the relation with set of ordered pairs 1, 4, 2, 5, 3, 6, 4, 7. This one is also a function since each element in the domain is assigned to no more than one value in the range. We have a one-to-one correspondence. So this one is a function. For number 3, we have the relation with set of ordered pairs -1, 4, 0, 5, 1, 5, and 2, 7. For this example, for example number 3, we have two elements from the domain 0 and 1 that is assigned to one element in the range, that is 5, and 2 is assigned to 7. This relation is a function since there is no equal abscisses that is assigned to the range. For example number 4, we have the relation with set of ordered pairs 1, 2, 2, 5, 2, 0, and 3, 7. For this relation, since the domain element 2 is assigned to two different values in the range, 5 and 0, it is not a function. For it to be function, we cannot have one value for x with two different values for y. So this one is not a function. Let us have more examples. Determine if these two diagrams are function or not. For the first diagram, the domain element 1 is assigned to two different values in the range 6 and 7, and 2 is assigned to 7. Therefore, this one is not a function since there is one element in the domain that is mapped to two elements in the range. For the second diagram, the elements 1 and 2 is mapped to one element from the range that is 6. Therefore, this one is a function. Let us see if this equation y is equal to 2x is a function or not by using a chart or a table. We have -2, -1, 0, 1, and 2 for the values of x. To get the values of y, we have to substitute each values of x to get y. The value of y, if x is -2, is -4. Next, the value of y, if x is -1, is -2. The value of y, if x is equal to 0, is 0 because 2 times 0 is 0. The value of y, if x is equal to 1, is 2. And the value of y, if x is 2, is equal to 4. We can also present this using a mapping diagram. As you can see, each element in the domain or each element in the input is mapped to exactly one element in the range or the output. Therefore, this is a function. Let us have another example. You have seen that not every set of ordered pairs defines a function. If we are given a set of ordered pairs, we can easily determine whether the relation is a function or not by simply looking if each first element is used only once in the given set. You have seen that not every set of ordered pairs defines a function. Similarly, not all equations with the variables x and y define a function. If an equation is solved for y and more than one value of y can be obtained for a particular value of x, then the equation does not define y as a function of x. Next, to determine if a graph is a function or not, we will use a vertical line test. Because not every graph in the Cartesian plane represents a function, and to know this, the vertical line test is the simplest way of determining whether or not a graph represents a function. So how do we use a vertical line test? A graph represents a function if and only if no vertical line intersects the graph at more than one point. So the vertical line should intersect the graph at exactly one point only. If it intersects the graph at more than one point, therefore, the given graph is not a function. Let us use the vertical line test to determine which graph represents y as a function of x. For the first graph, the graph is a function since the vertical line intersects the graph at exactly one point only. Next, the vertical line intersects at exactly one point again, therefore this graph is a function. Next, since the graph is a vertical line, obviously, the vertical line will intersect all the points of the graph. Therefore, this one is not a function. Next graph. For this graph, y is not a function of x since two values of y correspond to an x value. The vertical line intersects the graph in 2 points. This is not a function. Next graph. This is not a function since the vertical line intersects the graph in 2 points. Lastly, this is not a function since the vertical line intersects the graph in 2 points. For our third competency, we have the dependent and independent variables. There are two types of variables, the independent variable and the dependent variable. Let us see the difference between the two. The independent variable is a variable that will change by taking on different values. It changes independently. In a relation, independent variable controls the dependent variable. It is generally represented by the x variable or what is referred to as the x value. While the dependent variable is a variable that is affected by the independent variable and it changes in response to the independent variable. In a relation, the dependent variable depends on the independent variable. It is generally represented by the y variable or what is referred to as the y value. Let us have this example. Y equals f of x equals 3x plus 2. In here, the dependent variable is y and the independent variable is x. For this example, y is the dependent variable. Yung value niya nakadepende sa value ni x. While our independent variable is x because si x pwede siyang magkaroon ng iba-ibang values to get the value of our dependent variable y. So for example, find the value of y if x is 1. So yung f of x natin is 1. Ibig sabihin, pwede natin palitan si x ng iba-ibang value. So for this, find the value of y when x is equal to 1. So substitute natin yung value ng x na 1. So if x is 1, the result is 3 plus 2, that is equal to 5. So if x is 1, y is equal to 5. Let us assign a different value for x. Find the value of y when x is equal to 2. So substitute natin yung value ni x na 2 dun sa equation. This will give us 3 times 2 plus 2, that is 6 plus 2. Therefore, y is equal to 8 if x is 2. So, yung value ni y, nakadepende lagi kay x. So, nag-iiba yung value ni y, depende sa value na inassign natin dun sa variable x or dun sa independent variable. Let us have another example. Here's the scenario. In order to earn money, Robert cleans his neighbor's backyard for several hours during weekends. How much money did he earn? So, let us identify the two variables for this scenario. Yung independent variable natin dito is the number of hours cleaning. And yung dependent variable is the amount of money earned. How do we know which variable is independent? In this scenario, tignan natin kung alin ba yung dapat na mauna. Aling variable yung dependent dun sa isa or nakadepende dun sa isa pang variable. Yung independent variable natin dito is yung number of hours cleaning. Why? Kasi kailangan muna na magtrabaho ni Robert, maglinis ni Robert, bago siya kumita ng pera. Yung pera na kikitain niya, nakadepende lang dun sa number of hours na maglilinis siya. So, yung kikitain niya, nakadepende kung ilang oras siya maglilinis or magtatrabaho. So, that's how we identify the independent and dependent variable. That's all for this week. Thank you, grade 8 students, and God bless us all.